All right, class, this is chapter 10.2, CFU on concept 1, sampling distribution of the difference of two means, right? Difference of two sample mean, x1 bar minus x2 bar. So let's start. Let me also say something about what students should do. Students should be able to describe the shape, whether it's skewed left, skewed right, symmetric, bell shape, normal, and also describe the center, right? Maybe the median or the mean, and the variability. And that's variability. It's it's spread or standard deviation or IQR. So those are the three things you need to describe: the shape, the center, variability of the sampling distribution of the difference of the sample mean, all right? X1 bar minus X2 bar. So let's dive in. Researchers are interested in studying the effect of sleep on exam performance. Suppose the population of individuals who get at least 8 hours of sleep prior to an exam score an average of 96 points on the exam with a standard deviation of 18 points. Wow, 96 points. And the population of, so that's one population. So another population of individuals who get less than 8 hours of sleep score an average of 72 points with a standard deviation of 9.4. Suppose 40 individuals are randomly sampled from each population. So part A, describe the shape, the center, and variability of the sampling distribution of the difference of sample mean, right? X1 bar minus X2 bar. So it's an interesting question because when you read this, right, it gives you the mean, it gives you the population mean for the two populations, it gives you the population standard deviation for the two groups, but it doesn't really tell you much, right? You don't know whether is it skewed left, skewed right. You don't know if the two populations, if they are normal. You don't get a lot of information, and yet you're supposed to describe the shape of the sampling distribution, right? You're taking the sample from each population, and then you subtract them, right? You subtract the two sample mean, and then you keep doing it again and again and again and again and again, thus forming the sampling distribution. So, right, the mean, let's try to find the mean first, right? Mean, which is also the center. Find the mean of the sampling distribution of the difference of two sample mean, x1 bar minus x2 bar. Now, x1 bar minus x2 bar, it's the same thing as trying to find the population mean of x1 from the first population minus the population mean of the second population. So mu1 minus mu2. Now, at this point, we did not define what mu1 and mu2 is, so it will be good to define it. Okay, so it's the mean average points from the population who get at least, right, that's one group, at least and less than 8 hours of sleep score respectively, right? So it's mu1, let's say it's 96, the group that get at least 8 hours, and mu2, it's the 72, right? That's the group that gets less than 8 hours of sleep. So it's mu1 minus mu2, 96 minus 72, and you have 24, right? The mean score, the mean difference of the sample mean is 24. Now, why did we use the population mean when we are dealing with the sampling distribution? Because it's an unbiased estimator, right? When you want to estimate or want to find out what the mean of the sampling distribution is, we use the population mean, right? We use the population mean. In this case, is the difference. So we take population 1, the mean of population 1 minus mean of population 2. So how about standard deviation? Standard deviation, might be a typo. Standard deviation. Standard distribution. Oh no. So maybe let's backtrack. Okay, so all right, let's see. Standard deviation, and then let's see, of sampling distribution of x1 bar minus x2 bar. Cool. Okay, so all right, and then the symbol for that is actually the sigma of x1 bar minus x2 bar, right? And because this is a sampling distribution, we have to use the standard deviation. We're referring it to the sample, so we are changing it to S, right? S of sub x1 bar minus x2 bar, and we know that we cannot add variance. Sorry, we cannot add standard deviation, and we're not supposed to minus standard deviation. The only thing we can do when we're talking about standard deviation involving two populations is that you can only add variance from those two populations. So square root of sigma x1 bar square is to find the variance, right? Divided by n1. Okay. So this looks a bit confusing. So let me perhaps try to, so S x1 bar looks like this. Sigma S1 bar divided by root n. Remember this formula? Okay, so when we try to square this, it gives us this sigma x1 bar square divided by n. Because square root of n in the denominator, when you square it, it becomes n. So see the similarity here? Okay, I need to put n1. Okay, so the same thing applies to the second part. Okay, I hope you get this part. Okay, so I need to erase it. Okay, so then we substitute all the values. The standard deviation of the group 1, x1, is 18. So 18 squared divided by 40, n1 is 40, plus the standard deviation for the second group, second population, group 2, will be 9.4. Then you square it, divided by 40, and that gives us about 3.21. So the sampling distribution of x1 bar minus x2 bar will be a t distribution. Now, throughout the whole time that I've been talking about this question, we never once made any, like, hey, what's the shape, right? And then suddenly we say that this is a t distribution. Now, what's a t distribution? Why don't we say it's a normal distribution? So when you're dealing with quantitative data, right, and in this case, you're dealing with two different population of quantitative data, right? This is a mean score, right, exam score. And when you do not know, right, you do not know what the distribution looks like. And in this case, so when you do not know the distribution, and all right, okay, so I suddenly had a brain fart. So why is it t distribution? T distribution is used when your population standard deviation is not given. Then you might ask, hey, well, we know the standard deviation, the population standard deviation from group 1, right? From the population with individuals that get at least 8 hours of sleep. We also know the standard deviation, the population standard deviation that comes from the second group. So why do you say that we don't know the population standard deviation of the group? Now, you can have population standard deviation coming from two groups, but in this case, when we're taking the difference of the two groups, the actual population standard deviation of the difference of the two groups, we don't know that, right? That's an unknown. And when that's an unknown, we can only use what we are given. And we are given the population standard deviation of group 1, population standard deviation of group 2. Now we can use those two, but the actual population standard deviation of the difference of two groups, we don't know. So if you don't know the standard deviation, the population standard deviation, you can use T distribution, right? T distribution. In this case, we use T distribution with the degrees of freedom, n minus 1. So you need to remember degrees of freedom for T distribution is n minus 1. In this case, is 40 minus 1 equals to 39. So the mean will be about 24, and standard deviation will be about 3.21. All right, so part B, find the probability of observing a difference in the sample means of 2 points or more from the two samples. So yeah, I don't know if you kind of understand what the question is asking. So we're supposed to find the probability of observing a difference, right? The difference in the sample mean of 2 points or more, right? The difference of 2 points or more. So our original sample mean was what? 24, right? So if you were to, let's try to graph, right? We try to graph, the mean is 24 for this distribution, T distribution. And the difference, well, if we look at 22, the difference between 22 and 24 is 2, right? So how about 26? The difference between 26 and 24 is also 2. But they want a difference in sample mean of 2 points or more. So we're going to shade to the left of the 22, because anything less than 22, let's say 20, the difference between 20 and 24 will be 4, right? So that will be more than 2 points, right? They did ask you for a difference in sample mean of 2 points or more. So we need to shade then on the right side of 26. So notice that those two areas are what you need to find. And those two areas are symmetrical. So you only need to find one and you multiply by 2, and that works. So if you write out the probability of the difference of two means, x1 bar minus x2 bar, if it's less than or equals to 22, right? That refers to this area, plus probability of x1, plus the probability of x1 minus x2 greater than 26, okay? So we talked about the sampling distribution being a T distribution. So in a T distribution, we cannot use actual values like what we usually do in a normal CDF. So what can we use? So we must use the T statistics. So for example, in our normal CDF, we could have easily used our z-score, right? We could have easily use our z-score instead of the actual value. We use z-score, but if we use z-score, the mean will be 0 and the standard deviation will be 1, because z-scores are referring to the standard normal curve. So here we are using the T statistics, okay, with degrees freedom, right? You have to understand that when we deal with T statistics, we have to deal with the degrees of freedom. So T statistics has a formula quite like the same as your z-score, where you have the x minus the mean, mu, right? Mean divided by standard deviation. So same thing here, x minus mu divided by standard deviation, but this is a standard deviation of the sample. That's why it's s divided by root n. Okay, so let's put in the values. 22 minus 24. By the way, I'm calculating the T statistic, right? I'm calculating, let's say use a different color. I'm calculating the T statistics corresponding to this value. Okay, this particular value. So the x is 22 minus the mean, which is 24, divided by the standard deviation of the sampling distribution, which is 3.21. All right, 3.21. And I should probably erase this. Oops. Okay. All right, then continue. So TCDF, we can go to TCDF. Instead of 4 things like the normal CDF, TCDF is referring to the T distribution, but there are only 3 things you need. You need the lower bound, the upper bound, and the degrees of freedom. So we only need to find one area, right? One area. So we are looking for the one that is less than 22. So the lower bound will be negative 99999 because it's approaching to negative infinity to the left. And the upper bound is 22. Degrees of freedom is n minus 1, right? It's the sample size minus 1. So in this case, sample size is 40, minus 1 is 39. And then if you put that in the calculator, it's 0.2694 because there are 2 of them, right? It's symmetrical. So we take 0.2694 plus 0.2694, which is 0.539. Now I'm going to switch gear and show you on the calculator, okay? So, okay. All right, so we go to then second verse. You will see number 6, option 6, right? TCDF. And then it will ask you for a lower bound, which is negative infinity. We put a negative. Let's say put a negative 9999999. Put 999. Okay. The upper bound will be 20. Oh, sorry. You cannot put 22. We can only use the T statistics, which is, okay, we need to clear, what do we find the T statistics? Negative 0.62, right? Negative 0.62. I need to go back and see if I did put that correctly. Negative 0.62, that is the T statistics. Well, we don't call it T-score, but anyway. So degrees of freedom is 39. Yeah, look, 0.2694. If we multiply that by 2, 0.539. So let's switch gear. Yes, I did have the T statistics here. Oops, sorry. My T statistics is right here. Negative. So I said the wrong thing here. So here should be negative 0.62, right? The T statistics at this point is negative 0.62. Okay.